Okay, now let us proceed to chapter 3, which is dam outlet works. I hope these are just outlet works or dam appurtenant structures or ancillary structures, we can say. So dam outlet works consist generally of spillways and bottom or high head outlets. So these all ancillary structures can be categorized as dam appurtenant structures and also dam outlet works. So spillways are basically dam appurtenant structures, which is the largest appurtenant structures will be spillway. So we will see the design and also analyze. So outlet work structures can be classified according to their purpose, their physical and structural arrangement, and their hydraulic operation. So we will classify these outlet structures according to purpose, for what purpose it will serve, and also their physical and structural arrangement or their hydraulic operation. So let us see. So you can see these are just pictures of dam appurtenant structures. You have dam outlet works here, and this is buttress dam. So for this buttress dam, you have bottom outlet. So this is bottom outlet. So one dam appurtenant structure, and this is spillway, which is Ogee spillway with just a bucket type at the base at some point here. So it will just eject to this direction. And you can see this picture again. This is an embankment dam. So you have separate spillway, which is a spillway, chute spillway, and undersluice. This is undersluice. So you can open the undersluice portion just to dispose excess flood when it comes. So this is radial gate spillway. You can see again. So these are all dam appurtenant structures or dam outlet works, which means just conveying or just discharging excess flood or some extra flood when it comes. Okay, so you can see this picture again. This is arc dam with bottom outlets. So you may provide just bottom outlets just to dispose excess sediment that can be accumulated in front of the dam structure. So you can see this is just front face, which is upstream face of the arch dam. So when sediment is accumulated here, you can open this bottom outlet, but spillway is a little bit at higher elevation, and also intake structure must be above minimum pool level, which is just above dead storage level. So let us see. Now, spillway types and its design principles. Now, let us start. So, spillway is nothing, just it is a structure constructed to pass surplus flood water on the downstream of the reservoir and the dam. So, if you have excess flood, then you can just pass this surplus flood through the spillway structure. So, when reservoir is filling, then if it go beyond maximum reservoir level or above the crest level of the spillway, you can open just the gates on the spillway, then you can just discharge out. So what are the essential requirements of a spillway? So these are the following essential requirements of a spillway must be satisfied in every spillway. The first one is the spillway must have sufficient capacity. So it should have sufficient capacity. If the capacity is not enough to convey excess flood, then it may overtop on the dam structure. So that is not good. The downstream part may be eroded away. So we should be careful. And it must be hydraulically and structurally adequate. So hydraulically and structurally must be adequate. So, and also it must be located that it provides safe disposal of water. So safe disposal of water must be provided. And usually some devices are needed for energy dissipation on the downstream of the spillway. So once you convey this excess flood, then when it goes through the spillway, then at the bottom of the spillway, you need what? Energy dissipation. So the kinetic energy of the flow must be dissipated by providing some just a stealing basin, drop structure, etc., so that it can join the river safely without any erosion. Okay, so let us see now the types of spillway. So classification based on the time when the spillways come into operation. You have main or service spillway, and auxiliary spillway, and emergency spillway. So you may provide 2 or 3 spillways: main or service spillway, auxiliary spillway, and emergency spillway. So these are classification based on time when spillways come into operation. So classification according to flow through the spillway. So according to flow through the spillway, controlled or gated spillway. So you may have gated or ungated spillway, uncontrolled or ungated spillway, or gated spillway. So you may close the gates, then when it requires, then you can open the downstream part of the dam structure, or uncontrolled, just simply overtopping without the spillway. But the spillway crest level must be lower than the crest of the dam structure, which is at normal pool level. Okay, with respect to control structures, discharge channel, etc., the spillway is classified into the following types. So with respect to discharge channel, discharging or just hydraulically, just what flood magnitude that can convey. So you have free overflow or straight drop spillway, overflow or Ogee spillway, chute or open channel or trough spillway, and side channel spillway. Sometimes on the side of the channel you can provide when the reservoir is filling before it reaches the dam structure. On the side of the reservoir you can provide side channel spillway. Shaft or morning glory spillway, this is also sometimes you can provide, and conduit or tunnel spillway, siphon spillway. So these are major spillway structures with respect to control structures to the discharging channel. So these are the types of spillways. Okay, let us see. So you can see this, the first one is just an Ogee spillway with bucket type. So this bucket type is provided so that you can just make trajectory motion on the flow, so that it would just hit the river just away from the toe of the dam. So this is just Ogee spillway with just trajectory action, which is just away to the dam structure. And you can see this is vertical drop spillway, just it drops, but a small bucket type you can provide so that it will just go just as a trajectory motion, then it will hit. So once you have a river water, then you can just no erosion danger. But initially you have to provide stone pitching and some erosion protection structures. And you can see this is purely Ogee spillway, just touching the surface of the spillway, just making simply touching or gliding over the surface of the spillway. This is Ogee spillway, and this is just a separate spillway for an embankment, which is chute spillway, and this is Ogee spillway. So we provide a number of end gates of the spillway. It could be controlled or uncontrolled. Controlled means with the help of gates you can close and just open and close. But uncontrolled, simply open when the reservoir is filling by itself, it will discharge out without any problem. So this is just n number of gates you can provide depending upon the flood magnitude and also the reservoir capacity. Okay, so let us see now. So you can see this is just sharp crested spillway. So initially just with sharp crested weir started. So you have design head above that level, maximum reservoir level. So just when it fills this reservoir, it just ejects like that. So vertically drop initially. So due to that action or the flow pattern of this upper nappe and lower nappe, you feel what? Concrete. So concrete is filled, then it becomes Ogee Spillway. So an overflow dams with vertical upstream phase, let us see now. So the following equation, just as given by US Army Corps of Engineers, may be used for finding coordinates X and Y for the downstream profile. So you will just put this downstream profile coordinate. You start from here, X and Y to downstream direction, X to this direction. Then finally, you can draw using this equation. So for vertical upstream phase, X to the power of 1.85 equal to 2 times HD design head, the power of 0.85 times Y. But the general equation for any type of spillway is given using this equation. So X to the power of N equal to K times HD N minus 1 times Y. Now let us see the table. So X and Y are coordinates as shown in the figure, and HD is the design head that can be just generated above the spillway crest level. So you can just have center point here, peak point of the Ogee spillway, then you have X to the right direction, Y to down direction, then you can plot. So this is just the equation for upstream vertical phase, X to the power of 1.85 over HD, which is K is 2, then Y over HD. So this is a sample for vertical upstream phase. And also radius with respect to this one, upstream curve from this up to this. Smaller curve and larger curve, you can put R, both. Then you can go to this direction. So this is upstream curve, this is downstream curve, we will see. So overflow dams with sloping upstream phase. With sloping upstream phase, you have just downstream profile may conform to the following equation. You can use this equation, which is the previous equation. So N and K depends on what? The inclination of the upstream face of the dam. So depending upon the inclination of the upstream of the dam, you can just provide these components. Let us see. So these are the values of the constants K, N, R1, which is smaller radius as in the previous slide, R2, A, and DP. So these are just exponents. For example, for shape of upstream phase, for vertical upstream phase, K you can take 2, N, etc. So these are just values of constants with respect to shape of upstream phase of the spillway. So you can just use these values to draw the profile for downstream. But upstream profile should conform to the following equation. So this is, I think, with compound circular curve we can provide, which is, let me go back again. So upstream curve, this is the curve, I think, you can provide this curve. So let us see, you have this value, then finally you can provide. So upstream profile should conform to the following equation. Rather than these constants R2 over HD, A over HD, B over HD, you can use automatic this equation to plot the curve. For what value of X, you get Y value. You have a function of HD, design head, and also X distance. So you can provide upstream profile with this equation, downstream profile with the previous equation. So let us see discharge computation of over Ogee crest, which is this one. This one, you know this equation. The discharge over Ogee spillway is given by coefficient of discharge, effective length times effective head, the power of 3 over 2 or 1.5, where HE is effective head, design head plus approach head. So you can have this one. So HD design head, this one, then effective head, which is approach head, you can include. So this is kinetic head, V square over 2G, V square over 2G, approach head or kinetic head. So this effective length must be calculated. So the effective length of Ogee spillway is given by the following equation. This equation. This is just the net clear length of the Ogee spillway crest minus 2 times N times Kp plus Ka times He, effective head. So where L is the net clear length of the spillway crest and Kp is pier contraction coefficient and abutment contraction coefficient and number of piers. How many piers you have? Pier means in between the flat, you may provide pier. So it depends upon the shape of the pier. As you have seen in the previous slide, if you provide a number of gates, then in between the gates, you have what? A reinforced concrete structure. So that is a pier structure. So it could be rectangular or circular, etc. Depending upon the shape, you provide pier contraction coefficient. And the abutment, similarly, if the abutment is curved in plan and cross section, you have value, or otherwise, if it is a sharp corner, you have value. And thanks for watching this video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below. I will reply on it. Please like, share and subscribe this video to get more precise lectures. Thanks.